Hello everybody, it's Dark Shadow Codes here, and today we're going to be working with basically how to build um I'll show you at the end. But basically the overview is basically there's a bunch of rainbow particles everywhere into neat little sections where their particles should be based on the coordinates of where they are, and there's going to be droplets of rain. When you put your mouse over a particle, it'll enlarge, but it doesn't work on the rain. So let's begin. First, we get the normal HTML format. Then we're going to link style.css and script.js. There we go. And then we're going to create a canvas element. Then over in style.css, let's put our usual canvas format thing. Oops. Box sizing border box. Then we're going to go canvas, background, black. Width 100%, height 100%. Reload this. Okay, it'll work out in the overview. So that's all we have to do for now, I guess. Then script.js, let's create our canvas variable. Query selector. We want to select the canvas. Then we want to create a context element and get the context 2D from the canvas. Then we want to make our canvas have full width of the screen and full height. There we go. So that works. Then what we want to do is create a mouse variable and set its x to undefined and y to undefined. Then let's create an event listener that tracks the mouse moving right here. And we want to set the arrow function to have a parameter of ms for mouse. Then we'll set mouse.x to ms.x, and we'll do the same thing with mouse.y. Then just to make sure, I'll show you that later. For now, let's create our particle class. So it's quite easy. All you have to do is class particle, create a new particle class, and then we want to construct it for now. So this.x equals math.random times canvas.width. So it'll create a new particle. It'll create a new particle anywhere in a random spot on the x-axis, and we have to do that with the y-axis also. So math.random times canvas.height. So what math.random does, it basically generates a random number between 0 and 1, and it can generate 0 or 1, though it has a very small chance to actually do that. Then we want to create this to size equals math.size dot random times, let's say 2, 3, and then plus 2, so it has a minimum of, so it has a, oh wait, we have to round that so that it doesn't come up in errors, because when we're decreasing the size, when we're decreasing and increasing the size, then we don't want any errors to pop up. So then this dot color equals hue. We'll get to, oh wait, no, wait. This dot hue equals this dot x plus this dot y, and our constructing should be done. Oh no, wait. This dot dx, basically the speed of how much it moves on the x-axis, is math.random times 3 minus 1.5. There we go. Let's do the same with dy. That's some complicated calculus there. Don't be afraid, because calculus, I can't say that it's not that hard, but this part isn't that hard. So ctx dot begin path, so all the circles don't get connected. Then we want to say fill style is HSL plus this dot hue. So basically HSL is a CSS, well, a color function that stands for hue, saturation, lightness. So the first one is the hue, like 0 is red, 360 is red, 240 I think is blue or purple, something like that. No, I think 270 or 280 is, maybe 290. That's in the purple range. Anyway, 100% saturation, so it has full color, and then 50% lightness, so it's not, so it's correct. It has the correct lighting. 100% lightness is white, and 0% is black. You can play around with that to get familiar with color, with the HSL color function. Then ctx.arc, so we're gonna create an arc, a circle more specifically. So we want to go this dot x, this dot y, this dot size for the radius, and then 0 as the start, 0 as the start angle. Then that is the end angle, and then ctx dot fill. There we go. So we've got our draw method. Now we want to update. So we want to go this dot x plus equals this dot x plus this dot dx, or you can shorten it to this dot x plus equals this dot dx, this dot y plus equals this dot dy, and then let's see, we want to make sure particles bounce off walls. So if this dot x is greater than canvas dot width, so basically if it's touching the right edge, or if this dot x is less than 0, so if it's past the left edge, then this dot dx equals minus this dot dx. Oops, not 0, minus. So basically it'll reverse its x direction. So now let's do the same. Copy that, just to make things quicker. and change X to Y. Oh, and change canvas.width to canvas.height. So there we go. Now particles will bounce off walls. So now we want to test if mouse is in the range. If your mouse is in the range of the particle. So if mouse.x let's see. If mouse.x is greater than this.x, we've got a few what's it called? Ifs. I'll call them ifs. And if mouse.x is less than this.x plus this.size times 2, one second, I'll be right. Okay, sorry for the interruption, but wait, there are errors? Oh yes, I have to complete that if statement. So anyway, then, and mouse.y is in the range. So if mouse.y is greater than this.y, so if it's like, I can't explain it. Wait, let me figure out how to word this. Basically, if it's lower than the top edge of the circle, and mouse.y is less than this.y plus this.size times 2. So basically, if it's built above the lower edge of the circle. So we have our if statement. So now if that's true, then we want to put another if statement. If this dot size is less than, let's say 25, then this dot size increases by, let's say 1. Let's just increment it by 1. Then, oh yeah, else if the mouse is not on the particle and the particle size is this dot size is greater than, wait, so we have to create another variable called original size. So we'll set that to just the size and we'll call that original size. There we go. So if this dot size is greater than this dot original size, then this dot size decrements by 1. There we go. So we've got that. Now we have to initialize it and run it. So we're going to create a function called animate, just to like animate the entire thing. So ctx dot fill style RGBA 0.000, so, and then 1, so that'll leave trails when the circles are moving, the particles are moving. I have to get used to that, to calling them particles. Then we want to fill the entire canvas. Then we want to put a for loop saying iterating through the number of particle. Oh wait, yeah, I forgot. We have to put something crucial in. Particles equals an empty array. There we go. So if I is greater than particles dot length, I increases by 1. So we want to say particles I dot draw, and then we also want to update it. And then we want to request an animation frame of animate, so it'll basically put this entire thing in a loop once we just run it once. Because when you run it, it'll do all this code, and then it'll run the function animate, which is incidentally the function. Then we have to run animate, but you'll be wondering why it's not working, or maybe you're not, because we actually haven't added any particles to the particles variable. So we want to say we want to pull a function called init, which is for initialize, and then say for var I equals 0. If I is less than canvas dot width, I plus plus. So basically, it'll put as many particles as there are pixels in the canvas width. Then we're gonna go particles dot push, so it'll add a new object, and then we want to put a new particles object, and then we want to call init. So as we can see, it's all good, except the increasing thing isn't really working that well, because my mouse is only increasing the particle size when it's directly on the particle. So we can do that two ways. We can increase the particle size to make it increase better, or we can make the range bigger. So excuse me 1 second. Okay, so as we can see, this is our preview so far. And like I said, we need to make sure that there's a bigger range in which my mouse interacts with the particles. So to do that, we can fix this a bit and say -20, so it's 20 pixels to the left of the left edge of the particle, and then over here we want to do +20 pixels to the right edge, and the same over here, 20 pixels above the top edge, and +20 here, so 20 pixels below the bottom edge. So now, as we can see, it's much easier to do. But right now the colors are not neatly organized like I had planned. So once again, I'm going to copy this line right here because it only runs once and we want it to keep running so that it organizes the particles into neat little sections. So now, as we can see, it creates a nice rainbow effect that we can use. At the moment it's kind of laggy. I don't know if you can see it, but I don't like it. So over here we can fix that by, instead of canvas.width, let's just go 200 particles to make things easier. Forget that, that's way too little. Let's go 1000 particles. Okay, I'll be honest, that's barely anything. Let's go back to our canvas.width. Much better. So now if I can move my mouse around, get particles to enlarge. But at the moment they're not growing big enough, so that's a simple fix. All I have to do is change this to 35. Let's see how that turns out. Reload. Much better. Now, if I move my mouse over there, we can see that the particles that go near where I just left my mouse get bigger. So we don't want this because it's basically leaving the mouse in the last position it was in. So to change that, we can put we can set an interval arrow function, and then say mouse dot x equals undefined, and do the same with mouse dot y. If you're wondering why I'm not using null like I originally used, oh wait, I used undefined originally, but you can't use null. Okay, that was very embarrassing. I'd like to apologize. But you can't use null instead of undefined because the problem is it'll set your mouse position to 0, but undefined it won't be set to any number. So basically, if you set it to null, any particles near 0, 0, coordinates 0, 0 will basically grow larger. So we don't want that. That's the same as this pretty much, except in one specific spot. So this is a much better practice. So basically this will happen every 500 milliseconds. So as we can see, hopefully this doesn't lag as much as it is for me on your device, because that would be sad. Let's reload because, you know, for technical purposes, because it's lagging a bit. Okay, so it works perfectly. Now if we move our mouse off screen, you can see particles that go near our mouse's last position don't show. They show, sorry. They don't grow bigger. So there we have it. A nice, simple effect for our particles. But now we're adding the rain. Bet you didn't see that coming. So it's simple enough, much simpler than this particle thing. So we want to go class particle. No, not class particle. Let's call it class rain. Then constructor. Then we want to go this.x equals, once again, math.random times canvas width. Then this.y, we set that to 0. And then this dot size equals math.random times 2 plus 1. So basically random number from between 1 and 3. So if you're wondering why I didn't put math.round, it's because it'll be more random instead of either 1, 2, or 3, because in this case we don't have to decrease or increase the size will stay the same. So we put this.dy equal to let's say a random number from 3 to 7. And there we go. So we want to go draw our draw method as usual, and then ctx.begin path, then ctx dot fill style is white, ctx.arc, we want to create a circle, this dot x, this dot y, this dot size 0 math dot pi times 2. There we go. Then ctx dot fill, so the circle will actually show. Then we want to go and create an update method, and then say this dot y is increased by this dot dy. Then simple enough, if this dot y is greater than canvas dot height, so basically if it's past the canvas, then this dot y equals 0, so it'll reset it. And now all we have to do is over here, when we call init, we also call let's put like let's say 500 raindrops, and we'll say new rain. Then back to our animate function, we'll go oh yeah, we have to create so we'll call another array called raindrops. I'm going to define that in a sec. Var raindrops equals an empty array. And then we're going to say raindrops, and then change this to raindrops. And then now if we take a look at our perfect. So now we have our raindrops, sort of rain effect on our particle thing. So that combines pretty much 2 effects into one thing. And the best part is you can save this as an image. That's one of my favorite parts about Canvas. You can literally draw whatever you want. And then you can save it as an image and impress your friends, and they'll be like, whoa, where did that come from? And then you can say, I built it with JavaScript, and then they'll be like, you can't build an image with JavaScript. And you can say a bunch of complicated mumbo jumbo to them just to see the confused look on their faces. It's hilarious. But anyway, I hope you had fun watching this tutorial. Subscribe, hit the bell, and leave a like for more content. And maybe share the video with your friends and followers and family, because I have some awesome content and which you wouldn't want to miss, or you wouldn't want anyone else to miss. But then again, if anyone else misses it, then you'll know all this awesome stuff and be able to impress them, and they won't be like, and yo, I already know how to do that. They'll be like, whoa, how did you do that? But anyway, enough chit chat. Dark Shadow Code's out. Have a great day.